All right, guys, here's section 7.2, present value of an annuity. It's only a few slides long. It just adds one formula. Can be tricky to punch into your calculator, so you'll have to practice it, and the questions I've assigned are designed to have you practice it. So when we calculate the amount of an annuity, we're determining how much we'll have in the future. That's what we did in the last section, 7.1. So like saving for retirement or education or whatever. But in this section, sometimes we need a lump sum of money right now, and we're going to pay it off with regular payments as we go, like buying a car, right? One of the cars that I bought, I didn't have any money in the bank, but I knew I could afford a regular payment, and that's how I bought it. So now we have a different formula for calculating the present value of an annuity. It's, you'll notice the negative exponent in there, I'm sure, and there's a few other changes. P equals R, bracket 1 minus bracket 1 plus I, bracket to the power of negative N over I. But you'll see the things still mean the same thing. This is what we want to figure out. This is the regular payment that you can afford. This is the interest rate per compounding period as a decimal, and this is the total number of compounding periods. So it's, in that sense, it's the same. It's the same stuff, all right? So just two examples, and then we're out of here, guys. So suppose you want to finance a used car. You can afford to pay $200 per month for 4 years. The local used car dealership offers a financing rate of 5.9% compounded monthly. How much can you afford to pay for the car? So this is going to tell me how expensive a car I can afford if I can afford to pay $200 per month. So we're trying to find this. That's the price of car we can afford. R is the regular payment that you can make. So it says it's 200. I is the interest rate, 5.9%. So that's going to be 0.059 in decimal divided by, it says monthly, I believe. So that's divided by 12. I'm going to punch that into my calculator now. 0.059 divided by 12 is, unfortunately, it's a funny decimal. It's it's times 10 to the negative 3. It's going to be 0.0049, and I'm going to round the next digit to 2. Now, in real life, they would not round that. They would carry, it's a 6 repeating on my calculator. So it was actually 0.0049166666. But to simplify things, I'm going to put it to a 2 so I don't have to carry that giant number in my calculator. N's the total number of compounding periods. So this is 4 years, and it's monthly payments. So 4 times 12, I think, is 48. You can double check that for me if you'd like. So we've got our stuff. So let's figure out how expensive a car we can afford. So principal equals, or present value equals, 200, 1 minus bracket 1 plus the interest rate. That's my 0.00492 to the power of negative 48. That's all in brackets, all divided by that interest rate. I don't like how that spiked there. All divided by that interest rate of 0.00492. So it's probably best to do it step by step in the calculator. 0.00492 plus 1. So I just figured out in the brackets it's 1.00492. And then I'm going to go to the power of negative 48, hit equals, and it gives me 0.79. So I'm just going to write down what I have so far. So it's 200 bracket 1 minus, and I figured all that other stuff out to be 0.79. And that's closing my bracket, divided by 0.00492. I got to go 1 minus 0.79 in there, which gives me 0.21. So I'll just write that off to the side here. So it's 200 times 0.21 divided by 0.00492. I can type all that in at once. I'm going times 200. I'm going divided by 0.00492. And it says I can get a used car. I'm writing the answer right over here on the left because that's all the space I've got. $8,532.04. That's if you can pay $200 a month for 4 years, that is the car that you can buy, because there's interest rate every time you do financing. Some new cars, sometimes they'll offer you 0% financing, which can end up being a bit of a scam too, but that's how much you can afford there. Let's do one more. Cash for Life Lottery pays its winner $1,000 per week for life for 25 years, it says actually. If the Lottery Corporation gets 3% interest compounded weekly, how much do they need saved right now so they can make these payouts? So they can afford these payouts, all right? So again, we're finding out what this equals. It's $1,000 per week. The interest rate is 3%, 0.03, but it's compounded weekly. How many weeks are in a year? 52. So I got to go 0.03 divided by 52 weeks in a year, which is 0.000577. I'll leave it at that. And N is 25 years, and it's weekly. So 52 times a year times 25, it's 1,300. I just multiplied it. 52 times 25. Here, I'll write that down so you guys can see. So it's 25 years times 52 weeks in a year, which gave me 1,300. All right, now I got to put all that into the calculator. So I'm going to go P equals 1,000, 1 minus bracket 1 plus that interest rate of 0.000. Now, if you're good at scientific notation, you could write that as 5.77 times 10 to the negative 4, but I'm doing it without that. To the power of negative 1,300, close up my bracket, and it's all under the interest rate of 0.000577. All right, now it's calculator time. I type 1 plus 0.000577. That gives me 1.000577 to the power of negative 1,300, which gives me 0.47 and some other stuff. And I got to go 1 minus that, and it gives me 0.52. So basically, I get it to this 0.52. I'm just going to erase this. Just get rid of that. 0.52, 53. It's actually 0.527578498 divided by 0.000577. I don't know if I'll be able to cram my answer in there, not likely. So I got to go times 1,000 divided by 0.123577 gives me 914,000. So I'm going to again use this space over here. $914,000, 347 and 48 cents. That's how much money needs to be put down today so that the Cash for Life lottery has enough money to pay its winner for 25 years. So, that's the way that goes. And let's just move on here. The textbook section is here, and some delinquent teenager or teacher has already put stars beside the ones that I actually want you to do. I just want you to do number 1, number 2, and number 4. It's not that much work, but it might be more work than you'd think. Number 1, A, B, C, and D are just, can you punch these numbers into your calculator and get the right answer, right? So just attempt to do that and get an answer. Number 2, it gives you the R, the I, and the N value, and you figure out what the PV value is. Now, I know, I think in the formula, I just had it as P, but in the textbook, they use PV for present value instead of just P. It doesn't matter. It's the same thing. It's the same exact formula, right? So then putting those into the formula, again, practice with your calculator, getting it done. And then finally, we've got our last question, number 4, A, B, C, and D, where they give you a payment. That would be your R. They give you your interest rate, and they give you your frequency of compounding. So monthly would be 12 times per year. And then the length of the annuity is going to help you get your N, because it would be 2 years times 12 times a year. You guys know, you should, if you've been keeping up, have some practice with that now. So it's just 1, 2, and 4, guys. All calculations, nothing, no word problems or anything real tricky. 1, 2, and 4 on page 423. I'll try and remember to make sure I attach a picture of the questions to this, in case a few of you don't have your textbooks. All right, I believe that is all for now, guys. Good luck. Email me if you have any questions, and I will get back to you as soon as I can. All right, good luck.